Good afternoon, ladies and gentlemen. Myself, Devdat Bhattacharya, my teammates Kundan Kumar, Sushil Subramaniam, and Vivek Prashant Mishra from IIT Kharagpur are here to present fuzzy logic-based protection for image resizing by seam carving. Now, image resizing, the very thought of which brings two most commonly used techniques into our mind. One, of course, is scaling, and one is cropping. Cropping results in serious loss of information in an image because we cut out parts of the image, and scaling, as you can see, distorts the image. Now this brings us to image retargeting techniques. Retargeting techniques are quite recent and they are of great research interest. One of the retargeting techniques is saliency preservation. As the name may suggest, it preserves the salient features of an image. For example, if I were to resize this image using this technique, I would identify the salient features, which happen to be the boys and the ball there. We would pick them out from the picture, then resize the background by scaling or cropping or some other technique, and then paste them back onto the picture. Now the basic disadvantage of this method is that it is not photorealistic, in the sense that you can see that it separates the objects from the background, and as you can see the shadow of the football has become smaller but not the football. So it is not photorealistic, and another disadvantage is it takes a lot of time because it requires very accurate object detection. Another interesting and important technique is seam carving. A seam is defined as a connected row of pixels stretching across the length or breadth of the picture. Now, if you remove a seam, you can resize the picture. If you remove groups, it will get resized. However, seam carving is not content aware. It is photorealistic because it is not distinguishing between the objects in the background, but it does not distinguish the objects. Hence, what happens, as you can see, the seams pass through that guy on the extreme right and it distorts him. So, we require a technique which ensures photorealistic nature as well as object protection in an image. If we can strike a balance between the two, we'll have a good technique. Also, as we intend to implement the technique into mobiles, because we have to resize images to fit small screens, mobiles, PDAs. So if you have a low computation cost technique, it would be very useful, and obviously the technique has to be automatic without any user intervention.
Now to meet all these requirements, we have proposed a new method in which we have created a preprocessor for seam carving. This preprocessor consists of two low computation solutions. One is fuzzy logic image segmentation and another is neural network skin detection. And there is also a novel interface between the preprocessor and seam carving to achieve automatic retargeting. Now, seam carving, in which it has been told that in seam carving, first we calculate the energy image by calculating the energy for individual pixel, which is defined as the pixel intensity gradient. Then we calculate the lowest energy path, either from top to bottom or from left to right via dynamic programming. Then we remove seams one by one to resize the image. Now content unawareness comes due to the fact that an important object like this human being in this picture may have the low energy. So all the seams pass through them and the image is distorted. Here is an overview of our method. We first segment the image, we first segment our input image. Parallelly, we detect the skin. We merge both these two to get the humans protected. Then after adding all the weights, we do seam carving and get the output image. The first part of preprocessor is a fuzzy image segmentation. Now, for fuzzy image segmentation, we have taken the reference of a paper by Liu. The author has used subtractive clustering combined with fuzzy sequence algorithm. What subtractive clustering do? It predicts the number of clusters in the image, cluster of pixels in the image. Then it is given as input to the fuzzy sequence and it gives the belongingness of each pixel to each region. What we saw during the experimentation that this number of clusters was very high, predicted by this subtractive clustering. So here is a trade-off. Either we do with the same number of clusters, then we'll have increased computation cost, or we optimize it to get a low computation. After fuzzy sequence, we have the belongingness of each pixel to each region. Then we define three fuzzy membership functions to classify which pixel belongs to which region. These are region pixel distribution, closeness to a region center, and pixel specialization. All the mathematical equations and algorithms have been given in the paper fully. As you can see, the example of segmentation, as I told, the segmentation is not very good, but it suffices to work with seam carving due to its energy method.
Now, skin detection. For skin detection, we use a backpropagation multilayer perceptor neural network. For training, we take skin and non-skin pixels from World Wide Web, and actually we train two networks. One network we train with RGB format and the other network we train with HSV format. Because in RGB format, generally after training the network, it also detects red color as skin, and HSV, it also detects the brown color as skin along with the skin pixels. So basically we detect skin with both of them and take the intersection of both, and then there are some isolated pixels which are also detected as skin. So we use a window based technique to remove those isolated noise. We can see this skin detected image. Here we can see 4 different persons with 4 different skin colors, and all of them have been detected as skin. Here in the first equation, SD1 represents the skin detected by using RGB format, and SD2 represents the skin detected by HSV format. Now FW is the window which we use. There will be many windows which passes through the pixels, and if there is a isolated skin pixel detected skin pixel, then all the windows have a certain threshold value. If the number of skin pixels in each window is less than certain value, then it assigns 0 to all the pixels, telling that it's non-skin. So we take the intersection of this to get the final skin detected image. This energy function is the gradient of the pixel intensities, and by adding the normalized energy matrix and the new modified skin detected image, we get the final new weight matrix. As you can see in this picture, first we do image segmentation, and we do skin detection, and we combine both. Here what is done, that the skin detected in each clusters are taken, and the clusters segments get higher weight if the number of skin pixels is more in them. So they are protected while doing seam carving. This is our final flow chart. Here we take the input image, then we do fuzzy segmentation. Here in this part we do skin detection, and we combine both of them to get a modification of the weight matrix, and we find the energy function from the input image, and we combine the modification and the energy function, normalized energy function matrix, to get the new weight matrix, and the seam carving is done on this new weight matrix to give the final output.
We compare our method with a conventional seam carving method by analyzing the normalized average energy over the number of seams removed. As you can see, there is an initial dip in this curve. This shows that high energy pixels, or in the high energy seams, are not being removed. Are still being removed in spite of the content being high. In the sense, you can say that the content is high during the dip. Also, as the number of seams removed is high, as it keeps increasing up to 90 or 100, we see that the average energy of the resized image increases as a whole. That's showing that the photorealistic nature of the image is also retained along with the content protection. The key advantages and observations in our method is that fuzzy segmentation and backpropagation neural network are low computation in nature. Also, the fuzzy segmentation algorithm which we have used provides a better classification for ill-defined data, as we do not have to describe histograms and other statistical methods for defining the pixels into regions. Thus, we can conclude that weak algorithms combine to give excellent protection during the retargeting process which we have followed. The main applications of our method is retargeting for mobile and PDH displays, as Devdatta just said. Also, the low bandwidth transfer of images without content loss is also important. Also, we see in general criminal and medical image analysis involve a lot of human entities, and especially for example in the use of surveillance cameras. The retargeting method also has importance here. We have an example. The first example is an original image. This is 100 seams removed using the conventional method. As you can see, that the humans are getting thinned, and some portions of them have been cut out in the lower part. And with our improved method, they are completely protected. There is another algorithm where there are many distributed strikes clearly strikes a balance, and the protected resizing method is automatic. It can be easily developed in the software as shown, and most test images give excellent results. We like to acknowledge the following Flickr.com members for providing us with free photos by the Creative Commons.